Behind every legendary corporate titan lies a hidden strategy that ordinary observers completely ignore. Because while competitors obsess over building flashier products, master operators quietly engineer a system that makes failure mathematically impossible. How did a broken Swedish railway workshop, on the verge of total liquidation, stumble upon the ultimate hidden business strategy that would eventually outlast global competitors and conquer the heavy transport world? The secret wasn't brilliant marketing. It wasn't massive venture capital funding. It was a radical, counterintuitive philosophy of standardization that everyone else mocked. To uncover this hidden engine of growth, we have to peel back the layers of history to 1891, deep inside the industrial town of Södertälje, Sweden. A fledgling enterprise named Vabis was born with a singular, narrow focus: manufacture sturdy railway carriages for a nation expanding its iron roads. For a brief window, the model worked. Sparks illuminated dark workshops. Orders filled the ledgers. The founders felt secure. Then the inevitable market shift struck like lightning. National railway expansion slowed to a crawl. Orders vanished overnight. The factory floor went dead silent. Management faced a brutal reality: adapt or die. In a desperate bid for survival, engineers began tinkering with a loud, vibrating, unproven curiosity: the internal combustion engine. They started building early road vehicles from scratch, with zero supply chains, no established market, and cash reserves bleeding dry. Meanwhile, down in Malmö, a bicycle and machine works called Scania was hurtling toward its own economic disaster as cheaper foreign imports decimated its profit margins. Both companies were racing straight toward bankruptcy. And then, a brilliant stroke of strategic necessity occurred in 1911. They merged. They combined two failing balance sheets and two struggling workforces to form Scania Vabis. Most business analysts would have predicted immediate ruin, because combining two bankrupt firms usually just multiplies your problems. And multiply they did. The newly formed company collided headfirst with a massive operational bottleneck. Every single truck they produced was a bespoke, handmade creation. No two vehicles matched. If a gear snapped on a rugged logging trail in northern Sweden, the owner couldn't just open a catalog and buy a replacement. The broken part had to be mailed back to the factory, placed on a lathe, and painstakingly machined by hand. Repair times took weeks. Manufacturing costs spun completely out of control. The business was choking on its own custom craftsmanship. This is where the hidden strategy changed everything. While rival manufacturers chased prestige by building unique, custom-tailored trucks for every client, Scania's leadership asked a revolutionary question. What if we stopped treating every vehicle like a work of art and started treating them like industrial building blocks? This was the birth of the modular component strategy. Instead of designing hundreds of completely different parts, they engineered a core family of standardized components that could interlock seamlessly. A single engine block design could scale from 4 cylinders up to 6 simply by modifying the casting line. Gearboxes, frames, and steering linkages were standardized across the entire lineup. Competitors laughed at the idea, viewing uniformity as cheap and uninspired. They completely misunderstood customer psychology. Fleet operators and logistics companies do not care about artistic uniqueness. They care about uptime. They care about how fast a broken truck can get back on the road making money. By standardizing parts, Scania unlocked an invisible economic advantage. Production costs plummeted. Assembly lines accelerated. And if a component failed thousands of miles away from the factory, a replacement part could be pulled off a shelf and installed immediately. Buying a Scania wasn't just buying a vehicle anymore. It was buying absolute operational insurance. Yet, mastering production was only half the battle. As global trade expanded and international shipping lanes reopened after decades of geopolitical turmoil, a new frontier emerged. European borders dissolved into open economic corridors. Freight weights skyrocketed. Logistics companies no longer wanted small, localized delivery trucks. They demanded transcontinental heavy haulers capable of running 24 hours a day without breaking down. Most truck manufacturers attempted to meet this demand by rushing massive, unproven vehicles to market, resulting in catastrophic warranty claims and fractured brand loyalty. Scania took the opposite path. They looked inward at their modular architecture and asked, how can we scale our core building blocks into the heaviest commercial sectors on Earth without redesigning our factories? The answer was breathtakingly simple. They applied recursive modularity. Every single heavy axle, every frame reinforcement, and every cooling system was engineered to accept extreme loads while utilizing the exact same assembly jigs they already used for lighter vehicles. They didn't build a new truck. They amplified the system they already trusted. This operational discipline created a devastating moat against competitors. While rival brands spent years retooling plants and retraining mechanics for every new generation of heavy trucks, Scania's assembly lines hummed with unbroken continuity. Profit margins expanded even as material costs rose across Europe. Transport firms noticed the difference immediately. A fleet manager running 10 trucks could stock spare parts for 50 vehicles because every core component was interchangeable across years of production. The economic efficiency was undeniable. The company was no longer just surviving market shifts. It was dictating the economic rhythm of the entire industry. Yet, as fleets grew larger, a terrifying new operational risk threatened transport companies across the continent. Driver fatigue and maintenance blind spots. When a heavy truck breaks down in the middle of a tight delivery schedule, the financial penalty is catastrophic. Competitors built thicker steel bumpers and louder horns, assuming drivers wanted brute force. Scania dug deeper into human psychology and operational feedback. They realized that the true hidden value of a commercial vehicle isn't just physical strength. It is cognitive ergonomics and predictive reliability. They redesigned their cabin layouts around the driver, placing every control within intuitive reach, drastically reducing fatigue on grueling cross-border hauls. More importantly, they transformed their trucks into data-emitting nodes long before the digital age was mainstream. By embedding early diagnostic feedback loops into their modular framework, they allowed fleet managers to track wear and tear before a part actually failed. This turned the truck from a mechanical liability into a predictable, revenue-generating asset. The true power of this hidden strategy revealed itself decades later, when the trucking industry demanded massive, heavy-duty horsepower to haul extreme loads across brutal terrain. While rival companies panicked, pouring millions into risky, blank-slate engine designs that threatened to bankrupt them, Scania executed a masterclass in capital efficiency. Because of their modular architecture, their engineers simply dropped a legendary, high-output V8 diesel engine straight into their existing chassis framework. They delivered monstrous hauling power without tearing down a single manufacturing line. Competitors were left scrambling in the dust. Even then, the global market threw another curveball: extreme economic recessions and fuel price shocks that crippled logistics companies worldwide. When diesel prices doubled overnight, most transport firms faced instant bankruptcy because their fuel consumption was unoptimized. Rival manufacturers scrambled to redesign entire aerodynamic profiles from scratch, spending years in wind tunnels while losing billions in market share. Scania's modular system absorbed the crisis with chilling precision. Because their cab architecture and engine blocks were already standardized within a flexible matrix, they could iteratively introduce aerodynamic refinements and combustion optimization packages directly onto existing assembly lines without halting production. They didn't need a miracle. They relied on their systematic adaptability. Yet, even after conquering European highways and surviving global fuel crises, a deeper challenge loomed on the horizon: the digital and ecological revolution. As global carbon regulations tightened and software began to dictate fleet management, traditional mechanical engineering alone could no longer guarantee supremacy. Skeptics whispered that old-school heavy manufacturers would crumble beneath the weight of electric powertrains and smart software integration. Once again, the hidden strategy of modularity proved to be their ultimate shield. Because their vehicles were built from interchangeable structural blocks, integrating digital sensors, automated transmissions, and alternative fuel systems didn't require tearing up their manufacturing DNA. The software adapted to the hardware framework, rather than forcing the factory to reinvent itself from scratch. The poor mechanics and struggling wagon builders of the 19th century didn't conquer the global market because they had a crystal ball. They survived because absolute crisis forced them to invent a smarter system. The Griffin emblem roaring across modern highways is living proof that when failure backs you into a corner, a brilliant hidden strategy will always outlast raw luck.